All right, ladies and gentlemen, welcome back. 5.4 exponential and logarithmic equations. So we're going to be solving for x today, or whatever variable they throw at you. We're going to be looking at both the exponential and the logarithmic equations, as this just says, being able to solve any one of these types. All right, so this is a pretty in-depth, to an extent, lots of examples today. Looking at different ways to solve different types of problems that can come up, and hopefully this will help you out. All right, so let's start off with, there's two different types of properties that we're going to be dealing with. The first one being what's called a one-to-one property. And a one-to-one property is going to be something that's going to look a little bit like this. Now this isn't one-to-one yet, but this would be an example of an exponential equation that we would need to solve for x. So 2 to the x equals 32. Now, we could use logarithms to solve this equation. However, some of these equations lead a little bit easier, lead to a little bit easier answers if you know something about the number 32. So what I'm talking about a one-to-one property is we want to rewrite this one-to-one, and here's one of our one-to-one properties. We looked at this a few days ago where I said a to the x equals a to the y tells me basically x equals y. If you don't know, by the way, IFF means if and only if. So if I said something like 2 to the third equals 2 to the x, I know that x equals 3. It's the only way this is true. And this is a one-to-one property. The bases are the same, and then I can just compare the exponents. So that goes to show for this particular example. 2 to the x equals 32. Well, I know, and you might know, that 32 is 2 to some power. And if you go through that, it's 2, 4, 8, 16, 32. It's 2 to the 5th, which tells me in this case, x equals 5. Nice and easy. It didn't require a calculator. It didn't require logarithms at all, even though it's technically solvable with logarithms. Just more drawn out, and you would need a calculator later on. But you could say, okay, 2 to what power is 32? And since it's a nice number, we can write using this one-to-one property. The other one-to-one property that we looked at is for logarithms. So the first one is for exponentials. The other one's for logarithms, saying that log base a of x equals log base a of y, if and only if x equals y. I'm going to have a couple examples here of what this is going to look like. So ln of x minus ln of 3 equals 0. Now, some of you are going to want to go straight away to using our properties that we dealt with a few days ago, where we said, okay, minus means division. But this one actually leads a little better if I was to say, okay, what if I was to say, if I added natural log of 3 to both sides? So I get the natural log of x equals the natural log of 3. And I've now set up a one-to-one property. Well, if ln of x, or the natural log of x, equals the natural log of 3, that has to tell me that x equals 3. And it's as simple as that. And if you substitute it back in the original equation, natural log of 3 minus the natural log of 3 better be 0. All right, let's see something else here. Oops. What about 1/3 to the x equals 9? Well, here's where things start getting a little bit tricky, and you need a lot of number sense to work with some of these problems. Now, I know that this is actually a 3, but it's flipped over, so I can actually say that this is 3 to the negative x. And I can do that for anything. I know that 1/2 is actually 2 to the negative 1. I know let's see here. If I knew 1/4, that's actually 1 over 2 squared, which is actually 2 to the negative 2. So there's ways to get rid of these fractions by changing them back into negative exponents. Well, in this case, since it was 1/3 to the x, I can write it as 1/3 to the negative x to take care of the fraction. Well, in this same sense, I can rewrite 9 as 3 squared. Well, that's nice because, again, I've now set up a one-to-one property which tells me that negative x equals 2, but as I always say, I don't care what negative x equals. I want to know what x equals, so I'm going to divide both sides by negative 1, and I'm going to get x equals negative 2. And there's your final answer. Because 1/3 to the negative 2 power is 9. All right, so that's the last of the one-to-one properties, even though there's many different ways that these could show up. Something along the lines, actually, I think I have one coming up a little bit later. I'm going to hang off on that example there. The other property we're going to be using is the inverse property. And basically, you have to remember what inverse means. Inverse means undoes. Basically, in our sense, they undo each other. Like if I said x squared equals 169, you should know to square root both sides because it undoes the x squared. All right, so let's look at what this is going to look like here. Let me get rid of my little example there. And an example here would be e to the x equals 7. Now, I can't do this. I can't, so e to the x equals e to what? I don't know what 7 is as e to what power. So I can't set up a one-to-one property. So that doesn't work for me. But an inverse would work for me. So if I knew how to undo an exponential problem, I could use that to help me solve for x. So we're going to rewrite in inverse form, basically saying if I have an exponential equation right here, I could take the logarithm of both sides. Well, since this is, and notice I want the same bases. Well, this is base e. So if I was to take the natural log of both sides, I would end up with the natural log of e to the x equals the natural log of 7. And I really hope you were paying attention a few days ago because we simplified these already. Natural log of e to the x is x because the natural log and the e cancel. And so I'm left with x equals the natural log of 7, and that's just a calculator problem. Plugging that in the calculator, I get approximately 1.95, and I think you're rounding to the hundredths according to the textbook today. All right, so using a logarithm with the same base will cancel out the exponential problem. And likewise, if you're given a logarithmic equation, you could cancel that out by using an exponential or basically changing the problem back to an exponential equation. Just like we did before where we were changing logarithms into exponentials and exponentials into logarithms. That's basically what this ends up being. All right, so here's one of my big statements here. It cancels each other out. They cancel each other out, and that's the big idea, right? I always go back to the square root because you know if you can square root a number, it'll cancel out the square. All right, so if I had the natural log of x equals to negative 3, well, I can use this property right here because I'm given a logarithm, so I can cancel it out using an exponential. Basically, I want to take e of both sides. So I'm going to get e to the natural log of x equals e to the negative 3rd. And the same property applies here where they cancel, and I'm left with x equals e to the negative 3rd, and that's actually a number. So again, I'm just going to plug that into the calculator, e to the negative 3rd power, and I'm going to get approximately 0.05. See, this stuff's not too hard once you understand the properties between logarithms and exponentials and how you can use to cancel each other out. All right, let's try another one here. Log base 10. I know normally you're not going to see that 10 there, but for some reason the book wanted to put it there, so I'm going to put it there for now. So this is log base 10 of x equals negative 1. So since it's log base 10, let's use a base 10. Got to turn my pen on, I guess. So I'm going to go 10 for both sides. This is going to cancel, and I'm going to be left with x equals 10 to the negative 1st power which is 1 over 10, or if you like the decimal version, 0.1. And that one wasn't too hard at all. All right, so let's start looking at the more complicated problems. I know most of you don't really like that, but it's kind of how things have to work here. Everything can't be easy. If that was the case, we'd still be doing like third grade math. All right, so 3 times 2 to the x power equals 42. Now I know some of you are going to want to use, because it's exponential, I know some of you are going to want to use a logarithm right away, but you're not allowed to. You need to get exponentials or logarithms by themselves first. That's very important for a lot of the problems. Not every single one, but especially this one. The 3 has nothing to do with the exponential piece right now. So I'm going to divide both sides by 3. And I'm going to get 2 to the x power equals 14. And I want to use a one-to-one property here, but 14 is not a power of 2, which means I need to use a calculator. And so in this case, I need to take a logarithm of both sides. So I'm going to take the log base 2 because it's base 2 here. So log base 2 of 2 to the x equals log base 2 of 14. And I'm going to remember that these cancel each other out. I'm left with x equals log base 2 of 14. Well, I can't plug that into my calculator right now. So I'm going to use my change of base formula we did the other day. And in this case, I'm going to use natural log only because, like I said before, calculus uses this a lot, and higher level math classes use natural log more than they use log base 10. But you could do either one. But you have to do one that's on your calculator. So I like to natural log. So natural log of 14 divided by the natural log of 2. And I get approximately, not equal, but approximately equal to 3.81. And you could always plug that back into your into the original equation to make sure you did it right. So 3 times 2 to the 3.81, or it's going to be close because if you use a rounded number, so I'm going to say this, your calculator actually has a button called ANS. So if you know where that's at, use it because that's going to use the exact value. So 3 times 2 to the power of answer, and look at there, I got 42, which means I got the right answer. That's a good thing. We always like the right answer. All right, I wish it would stop doing that. Anywho, let's try e to the x plus 5 equals 60. So as before, I have to get the exponential by itself. So I'm going to subtract 5. That's pretty easy. And I'm going to get a very nice and simple e to the x equals 55. Well, I don't know how to change this to 1 to 1. So I'm going to take the natural log of both sides. Now when I do that, the natural log and the e are going to cancel. I'm left with x equals the natural log of 55, and that's the exact answer, but the approximate answer is natural log 55, 4.01. And again, you can always check. E to the power of answer, answer, plus 5 is 60. I got the right answer. What about this one? Purposely made this one a bit more challenging here. So I have to get the exponential piece by itself. So I have to get everything here by itself. So I have to get rid of this 4 and I have to get rid of this 2. And I have to do it in that order. So I'm going to add 4. And I'm going to get 2 times 3 to the 2x minus 5 equals 15. I'm going to divide by 2. I'm going to get 3 to the power of 2x minus 5 equals 7.5. You'll notice that I kind of ramped this up huge. Like there's more stuff to do in here than any of the other ones combined. All right, so now I have an exponential problem. I can't do anything with the exponent yet until I get out of the exponent. So what I'm going to do is I'm going to take the log base 3 of both sides. So I'm going to say log base 3 of 3 to the 2x minus 5 equals log base 3 of 7.5. Well, again, this is going to cancel this out, and I'm left with 2x minus 5 equals, well, I have to change this right-hand side to make it able to put on the calculator. So calculator going to be ln of 7.5 over ln of 3. And I'm going to leave that like right now. I don't really want to change that to a decimal yet, only because I don't feel like writing that decimal a whole bunch of times. So in order to get x by itself, so you got to remember that we're trying to solve for x, I'm going to add 5. And I have to add 5 outside the fraction. Come on, people. All right, so 2x equals ln of 7.5 over ln of 3 plus 5. And then I'm going to divide by 2. And I have to divide the entire thing by 2, by the way. So I'm going to get x equals, and I'm going to kind of write it like this just to not confuse too many people here. Because this is actually how I'm going to write this into the calculator. I'm going to do the natural log of 7.5. Actually, I'm going to use the parentheses that I have written. ln of 7.5 divided by the natural log of 3 plus 5, close parentheses, divide by 2, and I get approximately equal to 3.42. And I could plug that in my calculator. I'm going to do a quick check. I'm going to come up here. I'm going to say it's actually 2 times 3 to the power of 2 times answer minus 5 minus 4. Do a really quick check. 3 to the power of 2 times answer minus 5 minus 4. Oh, look, I got 11. That's good, because that's what I wanted in the first place. All right, moving on. One more. Let's see. Log base 3 of 5x minus 1 equals log base 3 of x plus 7. And some of you are going to look at this problem and go, what the hell? This problem seems way too hard. But you're going to forget, you forgot already about the one-to-one property. Since I have log base 3 of something equals log base 3 of something, that just tells me that 5x minus 1 equals x plus 7. It is actually as easy as that. Now you've got a nice linear equation that every single one of you better know how to do. Minus x. I'm going to add 1. And I'm going to get 4x equals 8, which means x is 2. And you better check your work just to make sure. If I plug in 2, I get 9, and here I get 9. And it's okay to take log base 3 of 9, so you're all good. Oops, got one more here. Thought I was going to the next page there. All right, 5 plus 2 times the natural log of x. This one's not too bad. I'm going to subtract 5 minus 5. 2 ln of x equals negative 1. I'm going to divide by 2. So I'm going to say, okay, divide by 2, divide by 2. I get the natural log of x is equal to negative 0.5 or negative half, whatever one you like better. And because I have the natural log, I'm going to take the e of both sides. So e and e. So I get that to cancel. I'm left with x equals e to the negative 0.5, which is approximately, if I plug it in my calculator, negative 0.5, 0.61. See, nothing too hard with these problems. You just got to take your time and work through all of them. Oh, dang it, I got one more down here. Try doing this one before I do it. Take a second, pause the video if you need to, do this one, and see if you get the right answer. All right, so dividing by 2, I get log base 5 of 3x equals 2. I'm going to use exponential, oops, not exponential base e, because that'd be silly. This is base 5, so I'm going to take base 5 of both sides. I'm just going to cancel that. I'm going to get 3x equals 5 to the second. Well, that's nice because 3x equals 25. Divide by 3, and I'm going to get x equals 25 over 3, which is approximately 8.3. And not too hard, like I'm just saying. Just follow along, do all the examples. No big deal. Stuff to be easy for you guys. All right, so there's obviously got to be harder ones, right? So you're looking at this going, man, these are way too easy. I wish there were some harder ones. Well, good luck. Here's some harder ones. So the biggest deal here is one of my first statements was get the logarithm by itself first. The problem is I can't get the logarithm by itself because there's something else going on the right-hand side, and I have 2 logarithms on the left. I can't set up a 1-to-1 because of this, basically because of this 2. So I'm going to use one big word here. The property of logs. I know I said one word, I meant 3. Okay, so logarithm properties tells me if I have the log or the sum of 2 logarithms, I can actually write it as the product of the 2 things. Which then means that I can actually change it now, because now I have 1 logarithm, so I can change it to an exponential problem. So this is, I hope you know that this is base 10 because there is no number there. So I'm going to go 10, the power of 10 to both sides. It's going to cancel that. I'm going to get 5x squared minus 5x equals 100. Right? 10 squared is 100. This, I've just distributed the 5x here and the 5x here. To make this problem a little bit more simple, I'm going to divide everything by 5. And I'm going to get x squared minus x equals 1. Oops, sorry, not 100. Silly. Equals 20. Now I have a quadratic. It shouldn't be anything difficult for you guys. X squared minus x minus 20 equals 0. X plus 4x minus 5. X equals negative 4. X equals 5. Now here's the issue. Here is where you definitely need to check your work. You're going to get, you remember this word here, extraneous. Means it's an extra answer. You're going to get one in this case. So if I plug in 5, 5 is an okay number because I'm going to get log of 25 plus log of 4, not a big deal. The big deal comes with this one. If I plug in a negative 4 into either of these logarithms, I get a negative logarithm. I can't do the logarithm of a negative number. So this is extraneous. This is my only answer. Okay, so when you start using your properties, actually you've noticed I've checked almost every single answer so far. I just checked to make sure you're doing them right. So when you start using your properties, you might end up with some extra answers. So in this case, 5 is the only answer. 4 is extraneous. A couple more examples here, and I'll let you guys go. Natural log of x plus 5 equals natural log of x minus 1 minus natural log of x plus 1. Well, I'm going to use some properties here. On the right-hand side, I have the difference of a logarithm. So that tells me to do subtraction. Division. Well, you might not see it right now, but this is actually a 1-to-1 statement. It's the natural log of something equals the natural log of something else. So I can set those two things equal to each other. And here you get to use your most favorite words, cross multiplication. So it's going to be, where do I want to go here? Let's go up here. It's going to be x plus 5 times x plus 1 equals x minus 1. And just got to go through the work here. Go through the process. Sorry, not 5. That's supposed to be a 6. Minus x, add 1. I get x squared minus 5x plus 6 equals 0. Sorry, plus 5x here. This factors to x plus 2, x plus 3 equals 0. So x is negative 2 and negative 3. And you got to figure out which ones don't work. So which ones don't work in this case? Well, if I plug either of them into this statement, the natural log of x plus 1, that's a big, big no-no. Can't have that. Which means this one doesn't have any solutions. Well, that's no fun for most of you. Some of you like no solutions because that means there's nothing left to do. But some of you don't like no solution because you just did a whole bunch of work for what you guys think is nothing. So in this case, it's no solutions because the only solutions that we had were negative, and that doesn't work. All right, so what do I have here? What's next? Oh, the next two problems are probably some of the most challenging ones to think about. Because you have to cross over from the exponentials that we're dealing with right now and the quadratics that this is going to look like. All right, so what I want you to think about here is this is really e to the x squared minus 3e to the x plus 2 equals 0. Well, the reason I write it like this is because now it should make you think about something like this. Something squared minus 3 times that something plus 2 equals 0. And this is what I was talking about, the quadratics. Well, I can factor this problem. This is an easy problem to factor. It's just going to factor like x minus 2 and x minus 1. Well, that's actually how these exponential problems work. Well, instead of doing x's here, I'm just going to do e to the x's. You can get rid of this quadratic because it doesn't actually exist. So it's actually e to the x minus 2 and e to the x minus 1 equals 0, which gives me two statements now. It says e to the x minus 2 equals 0 and e to the x minus 2 equals, minus 1, my fault. So e to the x equals 2, e to the x equals 1. Take the natural log of both sides, so ln, 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 ln. I get here the e's cancel. I get x equals the natural log of 2, and x equals the natural log of 1. I hope you can do the one on the right by yourself without a calculator. X equals 0, because the natural log of 1 is just 0. And the other one, you'll probably have to use your calculator. So the natural log of 2 is 0.69. All right. One more example like this that I hope you will try before I do it. Gosh darn it. Work. All right. What about this one? Try the same exact thing. Think about quadratics when you see this problem. Pause the video. Try to factor it yourself. Try to solve for x here before I do it. I'm going to go ahead because you can pause anytime you want. All right, so this is e to the x minus 5 and e to the x plus 1 equals 0, which tells me e to the x minus 5 equals 0, and e to the x plus 1 equals 0. So e to the x equals 5, e to the x equals negative 1. I can take the natural log of both sides, and I'm going to get x equals ln of 5. And here comes a problem. X equals natural log of negative 1. You might have gotten to this problem, and you might or gotten this far, and you go, oh, I plugged in the calculator, it doesn't work. You're right, it doesn't. That one's extraneous. The natural log of negative 1 does not exist because you can't take the log of negative numbers. But this one does. Ln of 5, 1.61. And there you go. All right, so those are your problems. You have your assignment on, I think I printed it on green for you guys this time. It's on the green paper. Your assignment should be in your folder somewhere. I hope this helped for you guys. I gave you guys a lot of examples trying to get every single type. But I know there's going to be something out there that you didn't see that I did. Just ask me questions. All right, I'll see you guys tomorrow.